using meshes with C# scripts, and we're also gonna see the creating a quad. And for that reason, you can create a project, so a new project, just 2D or 3D, and just pretty much create here. I already have it, and we are gonna create here create an empty, and we are gonna be creating this quad. So right now I already have the script for this particular project, so this is gonna be the script. And once you check out in the game, there's nothing, but once we play it, we're gonna create a quad, and there you have it over there. So we're gonna leave that in that. And using meshes with C# scripts, the mesh class gives a script access to an object's mesh geometry, allowing meshes to be created or modified at runtime. This technique is useful for graphical effects, e.g. stretching or squashing an object, but can also be useful in level design and optimization. The following sections pages feature an exploration of the API and an example. So again, we're gonna see the using the mesh class and creating a quad. That is gonna be very quickly. So using the mesh class is the basic script interface to an object's mesh geometry. It uses array to represent triangles, vertex positions, normals, and texture coordinates, and also supplies a number of other useful properties and functions to assist mesh generation. Accessing an object's mesh. The mesh data is attached to an object's mesh using the mesh filter component, and the object will also need a mesh renderer to make the geometry visible. This component is accessed using the familiar get component function. So here they give us examples. So again, it's very similar. Oops, let me close this one and make this one a little bigger. So again, we are having here using Unity Engine. So using Unity Engine, we have this public class example script mono behavior. Then we have the mesh filter mf semicolon at the end. Then we have in this function in the void start, we have inside of the curly braces the mf, and we are setting it to the get component mesh filter. So we have that. Adding the mesh data. The mesh object has properties for the vertices and their associated data, normals and the UV coordinates, and also for the triangle data. The vertices may be supplied in any order, by the arrays of normals, and UVs must be ordered so that the indices all correspond with the vertices, i.e. element 0 of the normals array supplies the normal for the vertex 0. The vertices are vectors 3s representing points in the object's local space. Let me see if I can make this one a little bigger. Okay, so much better. The normals are normalized. Okay, here the vertices are vectors 3 representing points in the object's local space. The normals are normalized vectors representing the directions, again in local coordinates. The UVs are specified as vector 2s, but since the vector 2 type doesn't have fields called u and v, you must mentally convert into x and y respectively. The triangles are specified as triples of integers that act as indices into the vertex array rather than use a special class to represent a triangle. The array is just a simple list of integer indices. These are taken in groups of 3 for each triangle. So the first 3 elements define the first triangle, the next 3 define the second triangle, and so on. An important detail of the triangles is the ordering of the corner vertices. They should be arranged so that the corners go around clockwise as you look down on the visible outer surface of the triangle, although it doesn't matter which corner you start with. Advanced Mesh API. The Mesh class also has a lower level advanced API that enables you to work with raw mesh vertex and index buffer data. This is useful in situations that require maximum performance or the lowest amount of memory allocation. So we have the mesh that set index buffers params and the mesh that set index buffer data for setting up size, format of the index buffer, and updating data inside it. Mesh that set vertex buffer params and the mesh that set vertex buffer data for setting up size, format of the vertex buffers, and updated data inside them. So we have the mesh that sets up mesh for setting up the index buffer topology and ranges. So finally we're gonna see this example, the creating a quad, and I already have it here. So let me see, this is gonna be we're gonna go way down, and this is the final script, but we're gonna start here. So to represent flat surfaces, Unity includes the plane and quad primitive game objects that you can instantiate in your scenes. However, it is useful to understand how to use a script to construct a quadrilateral mesh yourself. This is essential for procedural mesh generation. Note: Unity processes and displays geometry and triangles and not quads. This means that the quad primitive consists of two triangles. Vertex array. The first step you need to do is set up the array of vertices that your shape uses. This example assumes that the quad lies on the x-axis and y-axis, and that your script contains the variables width and height. So here we have this vertex 3 open brackets vertices. We are setting it to the new vertex 3. Inside of the brackets we are passing 4. Inside of the curly braces we're gonna have the new vector 3, and for the x position we have 0, for the y 0, and for the z 0. New vector 3 again, we're gonna have this time for the x position width, for the y position 0, and the z position 0. Again we have 0. Now the y coordinate is gonna be the height, and the z is gonna be 0. Then we're gonna have the width, the height, and 0. And finally we're gonna have the mesh that vertices and setting up to the vertices. Okay, so let me see. So we are having that piece of code right over here. Okay, so yeah, we have this vector 3, and let me see, we have this vector 3, and we are setting it right there. So yeah, that is the piece of code. And again we are having the using Unity engine, and then this public class name quad creator and mono behavior. Then we have we're gonna have the public void start, and also no, just the public void start. So we have that. It's very simple. We don't have the public update. Okay, so this example applies the vertices in the following order: bottom left, bottom right, top left, top right. Due to the way that Unity retrieves mesh data properties, it is much more efficient to set up data in your own array and then assign the array to a property. For example, to mesh that vertices or mesh that normals, rather than access the property array via individual elements. So here we have triangles. Next, you need to set up triangles. A quad consists of two triangles, each made up of 3 points in the vertex array you created earlier. To specify the points, you define each triangle as 3 indices of the vertex array. For example, the lower left triangle for this quad uses the index 0, 2, and 1, which correspond to the coordinates 0, 0, 0, 0, height 0, and width 0, 0. From the vertex array, the ordering is important because you must order the corners clockwise. Okay, so this is important. You must order it clockwise. So the upper right triangle uses the index 2, 3, and 1. Okay, so now we have this integer 3's, and we are setting it to the new integer, and inside of the bracket we pass in 6. Then we have the lower left triangle 0 to 1, and the upper right triangle 2, 3, and 1. Close this statement, this curly braces with a semicolon, and then we have the mesh that triangle, setting it to the 3's, and ended up with a semicolon. So let me see, and this is exactly what we have here from lines 26 to lines 33. Okay, we have this integer, we have open brackets, we have this name, this variable 3's that is setting it to the new integer, we pass in 6, and we have this information here. Okay, and now we have the normal. So a mesh with vertices and triangles is visible in the scene, but Unity does not shade it correctly because it has no normals yet. The normals for this example are simply because they are all identical. Every normal points in the negative z-axis direction and the quad's local space. When you add the normals, Unity correctly shades the quad, but you need a light in the scene to see the effect. So now we have the vector 3. Let me see right now. Okay, so now we're gonna have finally for the 35, it's gonna be from the 35 up to the 42. So we have the vector 3 open brackets normal, setting it to the new vector 3, and we're passing 4 inside of the brackets. We have this vector. Okay, So we have this vector 3 dot forward, then we separate with comma vector 3 dot forward, okay, 4 times, close this statement with a semicolon, and then we have the mesh dot normal, so we have to coincide with this variable and setting it to normals. Okay, if you do not want to define the normal yourself, you can use the mesh that recalculate normals. Okay, finally we have the texture coordinates. Finally, to display the texture finally to display textures on the mesh material correctly, add texture coordinates to the mesh. Texture coordinates are between 0 and 1. Each vertex in the mesh has a texture coordinate which specifies where on the material's texture to sample from. To show the whole texture across the quad, the texture coordinate values on each vertex should all be 0 and 1, so that each corner on the quad corresponds to a corner of the texture. And pretty much this is what we have here. This is vector 2, empty brackets, UV setting it to the new vector 2, empty inside of the brackets we have 4, and then inside of the curly braces we have the new vector 2, 0 0 1 0 0 1 and 1 1. Finally we have the mesh that UV setting it to the UV, and the mesh filter that mesh setting it to the mesh. And pretty much we already have all this code, so pretty much this is inside of the public void star, and then we just have this public flow width setting it to 1 and the public flow height setting it to 1 as well. And then this is the public class quad creator mono behavior. Okay, so this is the final script. The following script combines everything above to create a quad in your scene. To use it, create a new C# script, so you can go into this here pretty much and just let me see, like we can follow along here. Create a new C# script, so you go to assets, create, and then C# script. So what I like to do always is pretty much you go into the assets folder, and yeah, you can create a folder here and just name it, I don't know, scripts, and then just name it quad script or whatever, or just right click and then create, and then just grab C# script. So you do that, and now you can name it quad creator, so I name it something else. I name it quad script, so that's fine. Open the quad creator script, copy the example code into it, and save the script back in the editor. Create a new game object in your scene menu, game object, and create it empty. So that's what I did here. I went right click into the hierarchy and then just create empty. So this is what I have here. Okay, so we are gonna have the transform, and you are not gonna see this script. So what you can do is just grab this script from your asset and just bring it way over here to the game object. So I already have the quad script here. Okay, okay, so game object, create inspector, select a component script, quad creator, position the game object wherever you want in the scene. Enter play mode. If you cannot see the game view, make sure you are viewing it correctly. Okay, so let's give it a try. So we can just maybe put it like that and just click play, and here you're gonna see this the squad. So and we can play around, move it like this. Let me see, we are pretty much, you can we have it right here. It doesn't have any functionality, so let me see if I can lay out and then default the game, and the game is gonna be right here. You can make this one bigger like that. We can just leave it here, and now once you stop playing the game, the squad is gonna disappear because it's not really like a 3D object that we just summon like the cube, sphere, capsule, cylinder. Okay, and now let me see what else do we have here. This example code is in the start function, which means that it executes once you enter play mode, and the mesh does not change throughout the application. However, you can add the code to update the function to make the mesh change each frame. Be aware of this greatly increases the resources intensity of the mesh generation. And this is all that we have for creating a quad.